Good morning, dear students. My name is Ferhan Mazher, and today is 7th of April 2022. Right now, I am with the 11th Cambridge class, and the subject we are studying is Physics 5054. Today, we have set our hearts to solve a theory paper, and we have selected October-November 2012 2-2 paper. This theory paper, this paper 2 belongs from the zone 2, or you can say the variant 2. In this video, we are going to attempt the section A of this paper. The section B of this paper we will attempt in another video. So let's start today's paper. So here we go. Here is the question paper. So October, November 2012, 2-2 paper. Section A we are going to attempt. He says, describe an experiment. To verify the principle of moments, you may include a diagram in your answer. It's a 4-mark question. Let me reduce the size so you can see the whole thing. Okay. So let me show you. The method is very simple. Try to understand that. What we do, we take a rod of uniform thickness, and we put a pivot under its center of gravity, which is the center point of this rod. And then we take two different weights, and we know their weight, and we hang one weight on the left side of the pivot and one weight on the right side of the pivot with the rod, and then we move both the weights. It's kind of hit and trial method. So we move them, and we move them until we get a point that the rod is balanced on the pivot. Once it's balanced on the pivot, then we check the distance of the weight 1 from the pivot, and we check what is the distance. We measure what's the distance of the weight 2 from the pivot. Weight 1, because we have hung the weight 1 on the right side, so it's producing a clockwise moment about the pivot. And the weight 2, which is hung on the left side to the pivot, so it's producing a anti-clockwise moment. So when you calculate the moment produced by the W1, which is the clockwise moment, you will observe that the value is equals to the moment produced by W2, which is anti-clockwise moment. So this proves the principle of moments, which states that whenever a body is balanced in equilibrium, the clockwise moment and the anti-clockwise moment, they are equal to each other. So I have written this: hang two known loads, one on left side and one on the right side of a pivot with a rod. Move W1 and W2 until the rod on which they are hanging becomes balanced. Actually, the word should be balanced about the pivot. So when you will do the calculation, you will observe that the clockwise moment and the anti-clockwise moments, they are equal. So with the help of the diagram and with this description, I hope you will be able to understand this. It's a 4-mark question. The diagram is very important here because a lot is explained from the diagram. He says appropriate apparatus, for example, ruler, weights, fulcrum, action, for example, balance weight on each side. 1 mark is for this, 1 mark is for the correct apparatus. And one of the force and mass multiply distance or calculate the moment, vary or repeat. Okay, 1 mark is for saying that repeat this. So you can repeat that experiment by taking different weights or by changing their position on the rod. So I have not written that by repeat this because the space was over, but you can write it. I hope you can write a better answer. Okay, so that was a 4-mark question. Question number 1 is B part. He says figure 1.1 shows a spanner tightening a nut A force of 8 Newton is applied to the spanner at a perpendicular distance, of 0.15 meter from the center of the nut. Calculate the moment of the force acting on the nuts. Okay, so we know the force, that's 8 Newton, and we know the perpendicular distance between the pivot and the line of action of the force, that is 0.15 meters. So we can calculate the moment. The moment is force multiply the momentum. So it will be 8 multiplied 0.15. So let me show you my solution. So here we go. So 8 multiplies 0.15. So it will be 1.2 Newton. It's a 2 marks numerical. Hopefully you understand. So let's check them from marking scheme. 1.2 Newton meter. So our answer was also 1.2 Newton meter. So our answer is right. Question number 1 is done. Okay, so let's move to the next question. He says, a pupil hangs a load of 45 Newton from a length of copper wire. The wire extends by 2.5 millimeter and does not exceed the limit of proportionality. The gravitational field strength is 10 Newton per kg. Calculate the mass of the 45 Newton load. Okay, so here you have to calculate the mass. You know the weight is equals to mg. So if you want to calculate the mass, it will be W divided by G. Mass is equals to W divided by G. So just a simple and a very famous numerical which has frequently came in the Cambridge exam. So W is equals to mg, m is equals to W by G. So 45 Newton divided by 10 Newton per kg, the answer will be 4.5 kg. So it's a 1 mark numerical and a very famous numerical in physics exam. So let's check 4.5 kg. Our answer is also 4.5 kg. So our answer is right. Okay, he says use the grid in the figure 2.1 to plot the extension load graph for this wire for a load of between 0 and 45 Newton. So here a graph is given, and when the on the x-axis you will represent the load, and on the y-axis you will represent the extension. So, and we know 2 points. When there will be 0 load, there will be 0 extension. And when there will be 45 Newton load, the extension produced will be 2.55 millimeter. So it's a 3 marks question. Question is related with the graph of the extension. So here you can see that 3 marks question showing up on your screen. The answer is showing up on your screen. On the x-axis, I have represented the load. So every 2 centimeters represents 10 Newton. So 10, 20, 30, 40, 45. On the y-axis, we have represented the extension. So 2 centimeter represents 1 millimeter. So 1, 2, and 3. And we know 2 points. When there is 0 load, the extension is also 0. When the load is 45, the extension is 2 point something. Okay, so we have plotted those points. And then I have joined them with that black line. You can see that straight line, inclined straight line. So that's the extension load graph. It's a 3 marks question. Hopefully you understand. Let's have a look at the marking scheme. He says axis labeled with quantity and unit, linear scale, and the straight line from clear origin to correct point. Okay, so our answer is right. So then he says the next question, the next part, I mean, use the graph plotted in the figure 2.1 to determine the load needed to produce an extension of 1.3 millimeter. Okay, so we now know the extension that will be 1.3 millimeter, and I will try to find out what is the load when the extension is. So 1.3 is here. So from here, go to the extension load graph, and when you cross the extension load graph, below that point, check what's the value of the load. That is, I think, 23. Yeah, it's 23 Newtons. So let's have a look at the marking scheme. And let me show you my answer. 23 Newton. So this is our answer. So 23 Newton is the answer. So let's have a look at the marking scheme. What the marking scheme has to say. Answer from the candidate's lines. So I think our answer is, our answer looks the right. Look right. Okay, 23 Newton. Okay, so let's move to the next part. A man of mass 75 kg falls from a platform high above a lake. Figure 3.1a shows the man tied to the platform by a long elastic rope. We call it the bungee. And figure 3.1b shows the man when he has fallen 20 meter. After this point, the rope begins to stretch. Figure 3.1c shows the man at 25-meter below the platform, where he is first stopped by the rope. As the man falls, his gravitational potential energy changes. Okay, so here is that man standing on that platform and he jumps from here. So when he has fallen 20 meter, then the bungee starts to stretch. So here he has shown that after 20, the bungee has started stretching and he has reached the 25-meter below the platform. Okay, the question is the gravitational field strength is 10 Newton per kg. Calculate the change in his gravitational potential energy as he falls through 20 meters. So we know the mass of that 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 man, the mass is 75 kg, and we know that he has fallen how much, 20 meter, and the g value is also given. The fall in the gravitational potential energy will be mgh, and very easily we can calculate the loss in the gravitational potential energy. That will be 75 kg multiplied 10 Newton per kg multiplied 20 meter. So it will be 15,000 joules. 15,000 joules energy. 15,000 joules. Our answer is right. Question number 13a, first part, the answer is right. Okay. So then he says, when he is 20 meter below the platform, his kinetic energy is equals to the change in his gravitational potential energy calculated in the first part. Calculate his speed at this point. You know, he says at this point, the kinetic energy gained is equals to the loss in the gravitational potential energy, which we just calculated in the A first part. So make the kinetic energy equals to 15,000 joules. And you know what the formula for the kinetic energy? Kinetic energy formula is 1 by 2 mv square. So 1 by 2, the mass is 75 kg, the velocity at that moment we want to find out. And we already know that uh, so we know that the kinetic energy, we already know the kinetic energy is 15, the loss in the gravitational potential energy was 15,000 joules. So the gain in the kinetic energy will be also 15,000 joules. The formula for the kinetic energy is 1 by 2 mv square. So 1 by 2 into 75, mass is 75 kg. V is the question, equals to 15,000. So when I will make that V square alone, it will become 15,000 multiplied 2 divided by 75, and that will be 400. So take square root on both the sides, so you will have 20. So the final answer will be 20 meter per second. So the velocity at that moment will be, or the speed at that moment will be 20 meter per second. So you can see that our answer is right. So let's move. Next question. State the energy changes that takes place when he falls from 20 meter to 25 meter below the platform. Ignore the effect of the air resistance. Okay. So here the bungee has completely opened, and after 20 meter fall, the bungee starts to stretch. So when he goes below 20 meter, his kinetic energy is converting and his gravitational potential energy is also decreasing. So he has kinetic energy, he has some gravitational potential energy which is converting, and the obviously the when the bungee stretches, uh, so you have to do the work against the restoring force in the bungee, and that work which you do against the that restoring force in the bungee, that uh, that is stored in the bungee, and the energy which is stored in the bungee is in the form of elastic potential energy. Okay, so after 20 meter, when you fall down, you will have gravitational potential energy, you will have some kinetic energy. Both of them will be converting into the elastic potential energy of the cord, that elastic cord or elastic rope, you can say. So it's a 2 mark, it's a 3 mark question. Yeah. So let me show you my answer. So the potential energy and the kinetic energy will convert into elastic potential energy of the bungee. So that is a 3 marks question. Let's check the marking scheme. So 1 mark for saying that there will be gravitational potential energy at the start, and 1 mark for saying there will be kinetic energy at the start, and they will be converting to the elastic or the elastic potential energy. Yeah, elastic potential energy at that. So our answer is right. Figure 4.1 shows gas trapped in a cylinder by a piston. The piston has a cross-sectional area of 0.0050 meters square. It moves upwards through a distance of 0.074 meter, compressing the gas. During this compression, the average pressure of the gas is 4.6 x/5 Pascal. Calculate the average force exerted on the piston by the gas during the compression. So we know the pressure, we know the cross-sectional area, so we can find out the force exerted. And the force exerted, pressure is equal to force by area. So the force will be pressure multiply area. So 4.6 x/5 multiply 0.0050, and the answer will be 2300 Newton. 2300 Newton will be the answer. So let's have a look at the marking scheme. 2300 Newton is the right answer, sir. Okay, so we are going to the next part. He says the work done on the gas during the compression. We know the distance moved by the piston, and now we also know the force exerted on the piston. So very easily we can calculate the work done. The formula for the work done is the force multiplied the distance moved in the direction of the force, and that will be 2300 Newton multiplied 0.074 meter. So 170.2 joules. 170.2 joules will be the work done. So 170.2. Okay, so our answer is right. Okay, so let's move to the next part. He says the gas in the cylinder has a heat capacity. This is not specific heat capacity. Remember, this is only the heat capacity of 0.27 joules per coulomb, and heats up as it is compressed. Calculate the maximum possible temperature rise of the gas. Okay, so we have to find out the maximum temperature rise, and because this is the gas in the cylinder has a heat capacity. This is not specific heat capacity, and the formula is the change in the temperature is equal to the heat divided by the heat capacity. So the heat provided there is 170.2 joules, and the heat capacity is 0.27. So there will be a change of the temperature. How much? 630 degrees centigrade. 630 degrees centigrade. Then their question is suggest a reason why the actual temperature rise of the gas is less than the value calculated. You see, some of the heat is also lost to the surrounding through the cylinder. Okay, so some heat is lost to the surrounding, so that Our answer is right. If okay, so the thermal 630 is the right answer, sir. Thermal energy heat lost to the cylinder, environment, atmosphere, not just lost. Okay, so you have to tell where it went or work done against the heat loss due to the friction. One possibility is that there is friction between the piston and the cylinder. So when you overcome that friction, your energy will be converted into heat. You can also write that answer. Okay, so we are going to the next question. And the next question on your screen is question number 5. No thermal energy, heat is transferred from the surface of the sun to the earth by either conduction or convection. Explain why this is so. You'll see the transfer of heat by the conduction and convection. Both these methods of transfer of heat, they require medium. And because between the sun and the earth, there is no medium, there is space. So these two methods cannot transfer heat from the sun to the earth because they require medium. Conduction and convection require medium for transfer of heat. There is vacuum between earth and the sun, so the conduction and convection cannot take place. Only the heat is transferred by the help of infrared radiation. So space is a vacuum, empty. These methods need matter, medium, molecules, or do not occur in the vacuum. So these processes do not occur in the vacuum. Okay. So the next question and the next part is B part, and he says, in a certain country, question number 5, B part. In a certain country, the climate is very sunny and hot during the day and extremely cold during the night. Explain how painting the houses white helps to maintain a comfortable temperature both during the day and during the night. You see, where if you paint the homes or houses with the white color, so in the daytime when it will be very sunny and bright and the temperature will be high of the surrounding, the house, because it has white color on it, and the white color is a bad absorber of the infrared radiation, so the transfer of the heat from the surrounding to the inside of the home will reduce because the white color is a bad absorber of the infrared radiation. And during the night, when it will be very cold outside and you will have heating in the home, and the white color you have done on the home or house, that white color is a very bad emitter of the infrared radiation. So the heat will not be transferred at the night from the house to the surrounding because white color is a bad emitter of the infrared radiation. So these are my answers. So let's have a look at the written answers. Okay, white color is poor absorber of the infrared rays. So during sunny and hot day, heat will not be absorbed by the home. Or you can say heat will be a very small amount of the heat will be absorbed by the home. White color is bad emitter of the infrared rays. So during night, heat from home will be uh, lost at a slower rate. Heat will be lost to the surrounding at the night, but it will happen at a very slow rate. So hope you understand. So have a look at the marking scheme. What the marking scheme says. Okay, so B part, A part is done, B part. Any 3 day, white is a poor absorber, good reflector. Day, less heat absorbed, less heating. At the night, white is a poor emitter or radiator. Nighttime, less heat emitted and the heat loss anywhere of the infrared radiation. Okay, so that's the next part. Anywhere of infrared radiation radiant heat. What is this? Okay, question number 6. The filament in a cathode ray oscilloscope emits charged particles by thermonic emission. State the name of the charged particles that are emitted by the thermonic emission from a heated cathode filament actually, from a heated filament, the electrons come out of that filament into the air, and that is called thermonic emission. So the charged particle which is involved is electron. Then the question is explain what causes the particles to be emitted. You see, when you heat, and when you heat, so what happens? The atoms, they starts vibrating vigorously and at a faster rate. So when they collide with each other, they knock out electrons from each other, and the electrons are freed and they go into the air. Let me show you my answer. So the state the name of the charged particle that are emitted, that's electron. Explain what causes the particles to be emitted. When filament becomes hot, fast moving atoms knock out electrons from each other. So when they collide with each other, they knock out electrons. So state why there must be a vacuum in the cathode ray oscilloscope. You see, if you will not create vacuum in your oscilloscope, what will happen? The electrons will collide with the air molecules and they will not be able to reach the screen. When they will collide with the air molecules when they are traveling in the cathode ray oscilloscope, they will be stopped. Their kinetic energy will decrease. They might be deflected. So to avoid this, we create vacuum in the CRO. Electrons from heated filament or heat or boiled off from filament or knocked out by energetic fast-moving atoms. To allow electrons to reach the screen or no collision with the air, atom, molecules, or particles. He says the particles emitted have a charge of size 1.6 expo minus 19 coulomb. That's the charge on one electron, and carry a current of 5.6 into 10 raised to minus 3 ampere between the filament and the screen of the CRO. Calculate the number of particles that strike the screen every second. So we know the current and we know the time. So we can find the charge. I is equals to Q by T. So Q is equals to I multiplied T. So once you know the charge, you can divide that charge, the amount of charge, with the charge of the single electron, and you will know how many electrons are there. So it's a 2 marks numerical. So let's do it. I is equal to Q by T. The amount of current is 5.6 expo minus 3, and the time is 1 second. So the Q will be 5.6 expo minus 3 coulombs. Now, number of electrons will be divide that charge with the charge on a single electron, and you will get the answer. So 5.6 expo minus 3 divided by 1.6 expo minus 19, and that will give you 3.5 expo 16. 3.5 expo 16. So our answer is right, sir. So we are going to the next question. So we are going to the next question. The next question, question number 7. A small piece of metal taken from a nuclear reactor is radioactive. Describe a method to determine whether the piece of metal emits gamma rays. So what we will do, we will take a GM tube and we will check what is the reading of the background radiation. Then we will bring the sample and we will put the sample in front of the GM tube a few centimeters away from the GM tube. We will place that metal and we will note down what is the count rate coming on the GM tube. Then we will place a paper between the radioactive source and the GM tube, and you will see that there will be no change in the reading. It means so there are no alpha particles. Then remove the paper and place a aluminum foil of 5 millimeter thickness, and you will again observe that there is no change in the reading on the GM tube, which means the whatever the radiation is coming from that sample, that radiation cannot be stopped with with the paper, or that radiation can also not be stopped with a aluminum foil. So that means that radiation is gamma rays, because the gamma rays cannot be stopped by the paper or by the aluminum foil. So that's a 3 marks question. Okay, so let's have a look at my written answer. Use a GM tube to record the background radiation. Place the sample in front of the GM tube, few centimeters away from the GM tube. Note reading. Put a paper between the detector and the sample. There will be no change in the reading. Then place an aluminum foil 5 millimeter thick in the place of the paper. There will be no change in the reading. That shows the gamma radiation is coming. Okay, so the question number 7 is a part, a solid state detector, GM tube, ionization chamber, and sanitization, and counter spark, counter spin, uh, periscope, or count rate or reading referred to some detection with appropriate blocking in the way of the some reading track in the electric magnetic field, or film develops some detection from appropriate blocking in the way or some reading track in electric magnetic field, or diffusion cloud chamber tracks seen looked from afar or formed pattern of the track described. Okay, so that's the marking scheme of the question number 7A part. He says state two safety precautions that must be taken when handling the piece of metal. So when you are handling the piece of this metal, and the precautions could be that you have to reduce the exposure time, keep the exposure time minimum, and wear the leather lining suit. Any two lines, one distance method, tongues, robotic arm carry in large box, one protection method, for example, lead suit, lead gloves, lead boxes shield. One time method is reduce time or wear badge. So one good method is that you reduce the time of exposure. Question number 8 is coming up on your screen. He says the nuclei of 4 neutral atoms are represented using the nuclide notation. So carbon 612, carbon 614, nitrogen 714, and oxygen 815. Neutral atoms also contain electrons. State which of the 4 nuclei is surrounded by the greatest number of electrons. You saw the number of the electrons in a neutral atom are equal to the number of protons. So wherever the number of protons here are highest, there you will have the highest number of electrons. Here we go. So the oxygen 815 has 8 electrons. So that's the maximum number of electrons. Okay. He says from these 4 nuclei, he says from these 4 nuclei, state the 2 nuclei that have the same number of protons. So carbon 612 and carbon 614, they have the same number of protons. Nucleons, carbon 614 and the nitrogen 714 has the same nucleons. And the number of neutrons, same number of neutrons. If you check here, it has 7 neutrons. And if you check here, it has also 7 neutrons. If you check here, the neutrons are 8. Here the neutrons are, I think, 6. So where they have same number of neutrons, I think these two, they have the same number of neutrons. So let's have a look at the marking scheme. Okay. So the nitrogen 714 and the oxygen 815 have the same number of neutrons. So we are done, I think. Okay, my dear students, today we have completed the chapter number 8. Its marking scheme is showing up on your screen. You can pause the video and you can have a look at this marking scheme. So, my dear students, today we have done October, November 2012 and 2 paper. In this video, in this session, we have only solved the section A of this paper. The section B of this paper you can find in the same playlist on my channel, and you can see the section B. So the section A we have done in this video. The section B I'm going to do in the next video. So if you find this video interesting, and if you find that this video has helped you to solve this paper, and this can help your junior students, senior students, please do share the link of this video onto your Instagram and onto your Facebook and onto your Twitter accounts. And also like this video. So thank you very much. It's a great blessing for me to teach you online. God bless you all.